Okay, let's start with this first one where you're asked to find if the pair of vectors are orthogonal, parallel, or neither. And so I have this formula up here to kind of guide us. And so we need to compute this ratio right here. And that ratio, if it equals 1 or -1, then we're going to be dealing with parallel. The two vectors are going to be parallel to each other. And if it's 0, then they're going to be orthogonal, and everything else will follow under the neither category right there. And so what we'll do first, so by the way, on the orthogonal, if the dot product of the two vectors is 0, then automatically you can stop and they're going to be orthogonal. But to figure out parallel and neither, you actually need to go ahead and find this whole ratio right here. So let's start with the first one with all this information that's given to us right here. So let's start by finding the dot product of u and v. And so you just multiply the first components together and then add it with the product of the second components, which is -15. So that adds to -13. So we know what the numerator is, so it's not 0, so we automatically know it's not going to be orthogonal. And now we got to figure out what the denominator is. If the denominator is 13, or, well, it's going to have to be, it can't be negative, but if it's 13, then that ratio would be -1 and it would fall into the parallel category. If it's anything other than that, then we're going to be in the neither category. So I have to figure out the magnitude of u and v. And so, well, I'm going to start with u. The magnitude of u, what you basically do is you take the square root of each component squared. So 1 squared plus -3 squared. And so that'll give us the square root of 1 plus 9, which gives us the square root of 10. Okay. And then now I need to do the same thing for the v vector. So let's see, I'm going to take the square root of 2 squared plus 5 squared, so I'm going to get the square root of 4 plus 25, which is the square root of 29. And then if I multiply those together, so let's see, the magnitude of v times the magnitude of u is going to be, let's see, the square root of 290, which is irrational, and I'm not sure exactly what it is, probably around 15 or something like that, or no, 16, 17, something like that. But either way, you could put it in, and actually I'll go ahead and do it real quick so we can figure out what that angle is just for fun. So let's see, we're going to do the cosine inverse of, let's see, my numerator would be -13, and my denominator would be the square root of 290. And let's see, I'm getting 137.76 degrees, which, let's see, that seems to make sense. Okay. Yeah, that seems to be right. I can give you a little picture real quick. This is not absolutely necessary, but just so you can kind of see how this is working. So vector u is over 1 unit down 3 units, so it's kind of looks like that. And then the other vector is over 2 units and then up 5 units, so something kind of like that. So you can see that the angle between them is probably what I came up with right here, about 140 or whatever degrees between those two angles right there. But that was kind of extra, but just to kind of give you a visual of what's going on with these two vectors. Because on all these, you can, well, the three-dimensional one would be pretty hard to draw a picture of, but you can kind of draw a picture on the two-dimensional to kind of get an idea if you're in the right place. And it looks like you got part 2 correct, but we can. And it's done exactly how I did part 1, so maybe I'll skip that part. But once again, I just want to draw a picture so we can see that they are parallel. So the first one was, let's see, basically over 2 units up 3, so something kind of like that. And then the other one was back 6, down 9, so I'm like this. So I'm going in the opposite direction, but you can see it's on top of, they're on top of each other. And so yeah, they're parallel. They basically create a straight line. But if you want me to go over that one, just let me know. But it's done the same way. You want to find the dot product of these, then find the magnitude of each one individually. And what you'll see is the numerator and denominator should be the same, and that makes them parallel. Okay, the last one is going to be a little bit more work just because we're in the three-dimensional vector format. So we have to start by finding the dot product. And so it's done the same way that we did the first one. So u times v, we're going to multiply all the first components together, plus the second components multiplied together, plus the third components. Oh, okay, well this actually makes it pretty easy because, and I mentioned this earlier, it adds up to 0. So if you know the numerator is 0, you're good to go. You know that the magnitude of these, they have to, they can't be 0. And so, so you know that right there, so if you take the cosine inverse of 0, you'll see, cosine of 0, and you should get right there, 90 degrees. So, yes, so they're orthogonal, perpendicular, same thing, just a fancy way of saying perpendicular. Okay, so that's the first one. Let's go ahead and look at the next one. So right here it says, given vector u and vector v, choose the calculation that would be used to find the cross product. So this one's the cross product here. And so there's a couple of different ways we could approach this one. This way I've always kind of done it. I know the video probably has a couple different ways of explaining it, but the way I like to do it is I can have I, J, K, and then I'm a vector u, those components go below that, so 2, 3, 4, and then for vector v it's going to be 5, 7, and 9. And so the way I kind of like to do it is basically, for the first one, you kind of ignore the row 1 and column 1, and so I'm gonna take these numbers right here, 3, 7, 4, and 9. So I'm gonna find the determinant here and then multiply it by I, and then it's gonna be minus for the next one, and then I kind of do the same thing. I'm gonna erase this, but then I kind of cross this out and I write the determinant for the numbers that I have left right there. So once again, I'm going to take that away though. And so I'm going to have 2, 5, 4, 9, and then I have my j here, and then plus for my last one. And then same thing, I'm going to cross this part out, and I'm going to be left with this 2, 5, 3, 7, and a right there. Okay. So then I do the determinant, which basically multiplied that diagonally, so I get 27 minus, oh, actually I think I stopped here. Actually, they're not wanting us to go all the way. I think on another problem we actually will go all the way in a minute. But yeah, let me look. So yeah, there we go. That's what they want right here. And so we actually stop. We're not even asked to solve it completely. And so there we go. But there will be one in a minute where we will take it a step further, I believe. So let's see if it's this next one. So yes, this one, it's basically the same question, but they want us to actually write the whole thing out. So let's go ahead and try that. So once again, I'm going to have the I, the J, and the K, and then I'm going to put the numbers for my next row will be my vector u's components, and then below that will be my vectors for W, or my components for W. And then we're going to do that same thing that I just got done doing. So what we're going to do here is kind of just cross those out for a moment, just focus on this part of it, and then that will be my I component, and then we're going to have a minus. And then for J, be careful, it's going to be 8. That'll be for my J component. And then plus, and 2, negative 4, 7. And so here we go, we'll do the determinant. And then that should give me those coefficients. So let's see, negative 4 times 8 is negative 32, minus a negative 35. And so, let me go ahead and finish this part right here. So then the double negatives I'll add, so I'm going to get 3i. And then let's see, then minus, or what? Minus, and let's see, 2 times 8, that'll give me 16. Let's see, then minus this product going up should give me negative 15, and then I got my j. So I have those double negatives right there, so I'm going to end up adding that, so I'm going to end up getting a minus, it's going to be a 31j. And then, let's see, let's look at the last part here. So then I have a plus, so I multiply going down, which would give me let's see, negative 14. And then minus, multiply going up, negative times negative, I'm going to get positive 12. But that minus is part of the determinant process. And then times k. And those are both negative, so that will come together as plus negative 26k, but then we want to clean it up right here. It'll be considered a little bit more simplified if we just change that to a minus, and then you'll see that that's what we have as our answer over here. So 3i minus 31j, and then minus 26k, and so if you see, that's what we had up here. So I'm not sure, maybe if you did the magnitude or the I'm not sure if you did the dot product or something, so not sure. But anyways, if you have any other questions about this one, let me know. But I do have one more here. Let's see. So right here it says, find a unit vector in the direction of vector v. So the unit vector just means that we want the vector to be 1 unit long. And so this vector is multiple units long, and so all you have to do is find the magnitude of this vector and then divide each component by that magnitude, because you're basically finding the distance of the vector and then dividing each component by that distance, and that reduces the vector down to a single unit. And so that's what we're doing here. So if you look at all the answers, it's all the components getting divided by the magnitude of the vector, and so you just have to figure out which one is the magnitude of the vector. And so we found magnitude earlier. Let me go back to that one. So magnitude is pretty simple. You just you want to take the square root of the product of all the squares of all the components inside added together. You square root the sum of all those to get the that's what we're going to do here. So figure out the magnitude of v. We're going to do the square root of each of these components squared and added together. So we're going to have negative 2 squared plus 8 squared and then plus 4 squared. And so let's see, we're going to get the square root of 4 plus 64 plus 16, and let's see, when we add that all together, it should be the square root of 84. So that is my magnitude, and then what we do is we just divide each component by the magnitude, and that's how we get to this as our result right here. So everything's just getting multiplied by the magnitude. Okay, I hope that clarifies some things, but if you still have any questions, don't hesitate, let me know. I'll be happy to send you another video.